Hi, today we're going to do number 200, number of islands. So we're given a m by n 2D grid, which represents a map of land and water. 1 represents land and 0 is water. Return the number of islands. So we see here an island surrounded by water and is formed by connecting adjacent lands horizontally or vertically. So we see here this one here is all connected, so that's one island, and then this is connected there too, so that's all one island. So we return 1 here. Let's look, this 4 is 1, this is 1, and this is another 1, so we return 3. So we're going to have to traverse through this entire grid, and with this grid there's 2 main ways we can do this, either DFS or BFS. So with DFS, the logic is to traverse through grid through each value in grid. If value is 1, we do a DFS search. And here we're also going to need a count of islands, so count and increment count. And with this DFS search, we're going to do an edge case that if it's invalid, check if it's in bounds. Inbound. And then check if it's inbound, and also one. And then if it is, and then if it is, we update value to 0, so we know that we went to it already, and we don't recount it. And then we go up, down, left, right with it to call DFS again to see, to move up, move right, down, up, and left to make sure that we get everything in the circle and transforming them into 0. So here, and we return count. And here the time complexity is going to be O of m times m, since we have to iterate through this entire thing and then expand it again to get the time, and also the space complexity is also going to be O of m times n for the recursive call stack we have to keep adding it together. So the second way is to use BFS, and here we do the same thing, but we do a BFS search. And here, when you look at a DFS, we have this edge case that if it's inbound, if it's not inbound, we just return. In BFS, we don't even consider it unless it's inbound. So we do this one first, and then we add it to the, and then so where I'm going with this is that we find a value that's valid in 1, you add it to the queue. So in BFS, pop current value to queue, and then you just update value to 0, and then go up, down, left, right, and see if value is 1. So only if value is valid, which is inbounds, and 1, then we push it to the queue. And we just return count. And then it has the same idea. Time and space complexity is going to both be m times n, since we're iterating through, and then we can expand again as we find a valid one, and then we can create the queue for the length of the m times n. For every time we see a valid one, you can add the queue again for however long you expand it. So I would go with the DFS route, since generally it's simpler to go about it, and that's what I do first, but I'll show you both ways. So we do count, and then we return count at the end. And to make sure things are bound with the grid, we can create variables for the rows. Goes grid.length, and then const for columns equals grid, the first index going down. And here we have the directions going up and down. So we can do this all in the beginning. Equals, there's 4 main directions. So this would be down. So when because we're gonna be adding these values, you're gonna go down, and then go up. We have a -1, and then left and right, or here this is gonna be right, because we're gonna be adding these values, and -1 for left. So then we can go through all these directions to represent in the grid. Now we have a function of DFS, takes in row and column. And now we test our edge case. If row is less than 0, row is greater than or equal to rows, column is less than 0, column is greater than or equal to columns. Sorry, I need an or here. Sorry, not or. Yeah. Or is not a valid one. So grid row column is equal to 0. We return out of it. So now we update the value to 0 to indicate that we've been there. And then we want to go up, go all 4 directions. We do a for const, and we can destructure the values here. So change curve, change row, change call of directions. And we can get the values. So const new row equals change row plus this original row, const new call equals change call plus call. And then we just want to run DFS with the new row and new call. So we do this to traverse through each one, and whenever we see an eligible one, and turning and saying that we've seen it by converting it to 0. Now we have to call this, so we call it for as we loop through each value. So we need a nested for loop for that, and we can use row and call here as well to help us see what's going on. And then we only want to run this if the value is equal to 1. So we want to do a DFS, pass through row and call, and we want to increment island count. Oh, sorry, I forgot to do this. That's wrong. It would be 0 and -1 here. Great, so that's the DFS way, and I'll show you the BFS way. And actually, we're going to keep this logic count, rows, columns, direction, and we're going to change what goes here. And here, we're still going to iterate through each one and call BFS if the value is 1. So here we know the value is always going to be valid, so we don't have to set the boundaries first. So we create the queue const, and we know we can just push the value to the queue. And then we can also update the value to be seen by updating it to 0. Now we do a while loop while it's not empty, the queue. We pop. So current row, current column equals queue dot pop. And now here, we need to do BFS again for each direction. So for const, we can destructure it again. And we add it to the current one, so we can, let me change this to updated change. equals current row plus change row, const new call equals current call plus change call. And now we call and now we push it to the queue if the value is valid. So if new row greater than or equal to 0. So it's kind of like the opposite from when we do DFS. And then it has to be a valid one. And then we want to update the value to be 0 so we don't hit it again. Great. So these are two ways we can do it. The idea here, we're going to have to iterate through, do a nested for loop for each one, and then if the value is 1, that's where we're going to either do, we're going to update the count of the islands, and then we're going to either do BFS or DFS. With BFS, we create a queue, we push the value to queue, change it to 0, and then we do a while loop. The queue is not empty, pop it out, go up, down, left, right. If the next value is valid, we push it into the queue again and update it to 0 so we don't repeat it ourselves within the line of the queue. While with DFS, we're going to recursively call it with the base case being it being out of bounds, and we just return. Otherwise, we update the value to 0 and keep calling it until we reach the base case. And that's all. Thank you so much.